Okay, so here we have some normal distribution questions, and this time we are asked to find the unknown parameter. Either mu or sigma was unknown, and we need to find it. Now, a quick heads up, this is the only time where you must use the standardization formula. In all other instances, you actually have a choice and you could probably just use your calculator functions to get you through. But if you are looking for unknown parameters, this is the place to make use of the standardization formula. Okay, so the important things to start with are the probability, which we have, and a real life value, which we have, 129.2. This value has 20.6% below it. Is this value on the left-hand side or the right-hand side? The left-hand side or the right-hand side? For there to be 20% below it, it must be on the left. So here's where I'm going to put the marker. This is 126.2, 20 or 0.2063. And even simply, we know the middle number is 141. It's the mean. So we must be on the left-hand side of the mean if we're working with 129.2. Okay, I also can find what z-score would match 129.2. What z-score would correspond with 129.2? It's going to be a z-score that has the same percentage below it. So using the inverse function on our calculator, I want to know the z-score that has 0.2063 below it. For the standardized distribution, we use a 1 for the standard deviation and a 0 for the mean, and we get negative 0.8193. This is the z-score that matches the real life x value 129.2. Now, we have a formula, the standardization formula, that links the z-score to this real world value along with the two parameters, the mean and the standard deviation. Okay, so I'm just going to substitute these along with any other information we have into the formula. The other thing that we do know is the mean. Okay, so these two are going to be substituted into the formula. So negative 0.8913, here's my x value, and the mean, we do know, that was given to us, 141. Okay, all of that, just substitute into the formula. I don't need a calculator yet. I can just rearrange to make sigma the subject. Sigma is going to be this calculation in the numerator over the z-score. Now I'll reach for my calculator and I get a value of sigma 14.28. Okay, so a sensible use of the diagram helped us to decide the z-score that matched with the real world value. We substituted into the formula and we rearranged for what we were looking for. In the next question, we don't know what the mean is. We do know the standard deviation this time, but we're going to go through some similar steps. My real world value and my percentage. Where should 70.7 go to make sure that there is 89%, 90% above this marker? Is it on the left or is it on the right? I need to put it on the left to ensure that there is a large proportion above it, 90% above it. With an unknown mean, we had no idea what the middle number was, but this is the logic that helps us to place it. So 70.7 over here on the left, and we have 89.59% above it. Once again, this is not calculator ready. Our inverse function needs to know the probability on the left. So a little 1 minus gets us this red area, which is what we're going to work with, 0.1041. In the inverse calculation, I can say the inverse of the probability on the left with a 1 and a 0 because I want the standardized score, and that's going to equal negative 1.2585. That is the z-score that matches the real world value 70.7. Now, these can go into the formula, the standardization formula, along with the standard deviation we were given earlier in the question. So just substituting each of those things in. The only unknown is mu, and I can just rearrange to solve for mu. So multiply by 5.8. I don't need the calculator, I'm just going to write an expression. So z-score times 5.8, subtract 70.7, that's going to be negative mu. So whatever answer I get, I multiply it by -1, and we get mu equals 78. Okay, so unknown parameters, we found an unknown standard deviation, we found an unknown mean. On the way, we had to ensure that the values we were working with were calculator ready. A lot of students are going to sacrifice accuracy because they don't want to draw a diagram that takes 10 to 15 seconds to produce. We don't have any luxury to be sacrificing marks from silly mistakes because we didn't invest in a diagram. So I'm insisting on a diagram each time from you, making sure we pick up the correct probabilities, the correct areas, and substitute into the formulas correctly.